All right, let's play detective. Today, we're grabbing our magnifying glass and diving into the world of financial data. We're on a mission to see if we can use some public information and a little bit of Python code to predict if a company is secretly heading for trouble. So here's the big question, right? Can we actually listen to the market, sift through all that noise and all those numbers, and find a real, tangible clue that a company might be about to fail? It's a massive mystery, and today, we're going to try to crack it.
So what's our mission exactly? Well, we're on the hunt for something called the probability of default. And this isn't just for fun, this is incredibly important stuff for anyone who invests in or lends money to a company. It's all about understanding their true financial health.
Now, the key piece of evidence we're looking for is this thing called the probability of default, or PD for short. Think of it like a percentage, a score, that tells us the odds that a company is going to miss a payment on its debt. If that happens, well, that's often a direct path to bankruptcy. This is the smoking gun we're trying to find. Okay, here's a key part of our strategy. We're not just looking at any old data. We're zeroing in on a company's bonds that are due in the next 1 to 2 years. And you might be asking why? Well, it's because the prices of these short-term bonds are super sensitive to the company's immediate health. They give us what's called a market-implied signal. It's like we're listening in on what investors are whispering about the company's risk right now.
Every good investigation starts with gathering evidence. And for us, that means getting the data. So let's gear up for what is basically a data heist.
Our target is the Financial Industry Regulatory Authority, or FINRA. Specifically, we're going after their trace database. You can think of this as a giant official vault packed with all the corporate bond data we could ever want. It's our primary crime scene.
Now, to pull off a clean heist, you need the right tool. We're using a Python library called Playwright. You can think of it as our high-tech gadget. Unlike older tools, Playwright is smart. It automatically waits for a web page to finish loading before it tries to grab anything. This is a huge deal on modern websites and makes our data gathering mission so much more reliable.
And here's the plan of attack. Our little automated script follows 4 simple steps. It tells the browser to go to the website, type in our target company and the dates we care about, click the search button, and then zip. It copies the entire results table. It's like having a lightning-fast robotic assistant doing all the tedious work for us. Okay, so the heist was a success. We got the data, but when we get it back to our lab and lay it out on the table, yikes, it's a mess. This isn't a neat, clean spreadsheet. It's more like a crime scene where the evidence is just scattered everywhere and pretty much useless as it is. Just take a look at this. At first glance, it looks okay. You see names and numbers, but look closer. See that third row? There's just an empty space where the coupon rate should be. Little problems like this, missing information, are hidden all over the place, and we have to fix this stuff. And here's the real kicker. When Python first looks at this data, it doesn't see numbers or dates. It just sees everything as text, as a bunch of letters and symbols. And you can't do math with text. You can't calculate a yield if the price is just a word. This stops our investigation dead in its tracks.
So this is where the real detective work kicks in. We have to roll up our sleeves, put on our forensic gloves, and start cleaning this messy evidence. It's time to open up our data toolkit.
First tool out of the bag, a function called toNumeric. It's a simple one, but it's absolutely crucial. We just point it at the columns that should be numbers, like the price, and it magically converts all those text strings into real numbers we can finally use for math. Next up, toDateTime. This one tackles our date problem. It takes that maturity date column, which is just text, and turns it into a proper date format that the computer actually understands. Now we can do things like calculate exactly how many days are left until a bond matures. And our final tool is for dealing with incomplete evidence. A good detective knows you can't build a case on bad information, so any bond that's missing a critical clue, like its yield, is just too unreliable. We use a function called dropNA to just toss those rows out. We only want the good stuff. And what's the result of all that cleaning? Success. Take a look. Our data types have been completely transformed. The columns with numbers are now recognized as numbers, and the date column is a real date. Our evidence is finally cataloged, cleaned, and ready for some real analysis.
So after all that scraping and all that cleaning, we finally have it. We've taken a jumbled mess of text from a website and turned it into a structured, clean, and totally reliable data set.
And here it is. It's beautiful, isn't it? Every column has the right type of data, all the numbers are formatted perfectly, and any incomplete evidence has been removed. This is the solid foundation we absolutely need to finally start cracking the case and calculating that probability of default. So, we've successfully gathered and cleaned our evidence. All the hard prep work is done. The big question now is, what secrets are hiding inside these numbers? What story is this data about to tell us about the company's future? Well, that's the next step in our investigation.